We've been able to take NASA to record levels of funding. This last year's level included $184 million in emergency funding to address the damage that would occurred at NASA facilities at Michoud as a result, and at the Cape as a result of a hurricane and tornado. That was, I know, an important part of keeping NASA whole and allowing you to focus your efforts on spaceflight. This Congress has provided really significant increases to NASA. You've been underfunded for far too long. Too much has been on NASA's plate, and you haven't had enough funds to do everything that you've been asked to do. But that's changing, as you've seen with the last several appropriations. NASA has grown from $18.1 billion in funding in 2015 to almost $20 billion in fiscal year 17. It's an indication of the level of confidence, the level of admiration that the Congress and the people of America have in you and the good people at NASA, that we've been able to provide NASA with growth at this levels when other agencies of the federal government have seen their budgets held flat and even cut or eliminated. This, of course, increased funding requires increased responsibility. Our constituents' hard-earned and very scarce and precious tax dollars need to be spent wisely, prudently, carefully, and the subcommittee expects that you and everyone at NASA will ensure that money our constituents work so hard to earn is used frugally and carefully. We have, in the 2017 appropriations bill, made sure that the SLS rocket is fully funded, the Orion program is fully funded, that the agency has the funds that you need to put humans back into deep space. The commercial sector is funded at a level it should be in the 2017 bill. I like to think of what the commercial providers are doing as sort of like stepping out in front of your office building and catching a cab. In years to come, you should be able to catch a commercial provider to take you to low Earth orbit as easily as you can catch an Uber or Lyft or a yellow cab, and then NASA will be responsible for deep space travel. I think it's a good way to think about the distinction and the difference between them. And in addition to fully funding the human spaceflight program, as you've seen in the 2017 bill and in previous bills that I've had the privilege of chairing the subcommittee, the committee made certain that the decadal survey recommendations of the American Academy of Sciences are funded in each one of the major categories, because we want to see NASA fund and fly those top recommendations of the decadal survey, and in particular when it comes to planetary science, which was badly underfunded for too many years. And the committee included a directive to NASA, a statutory directive that NASA fund and fly a mission, an orbiter, and a lander to Jupiter's icy moon, Europa, because it's the one place nearest to home that the scientific community believes we're most likely to find life on another world for the first time in human history. So I look forward to hearing an update on how the Europa mission is going. And then finally, I also want to direct your attention and would ask you at some point, perhaps during the questioning, we'll talk about this as well, that the subcommittee included language in the 2017 bill directing NASA to identify the nearest Earth-like planet around the nearest star, characterize that nearby planet's atmosphere, looking for signs of life, methane, carbon dioxide, oxygen, and as John Grunsfeld once told me, perhaps the sensitivity would be such that we might even detect industrial pollution in the atmosphere of a nearby planet. And then to directing NASA to develop interstellar rocket propulsion, achieving 10% of the speed of light, and then launch humanity's first mission to that nearest Earth-like planet no later than the 100th anniversary of Neil Armstrong setting foot on the moon in 2069. I am particularly, I have in the time it's been my privilege to represent the people of West Houston in District 7, enjoyed my service on this subcommittee immensely, and an important part of that has been the friendship and close cooperation that I've developed with my good friend from New York, Mr. Serrano. I'm really pleased to have you back as our ranking member. We work together so well, and he is as passionate a supporter of the space program as I am, and I'm pleased to recognize the gentleman from New York for any opening remarks he'd like to make.
Thank you, Mr. Chairman. And I also welcome the administrator to the subcommittee hearing today. NASA is in charge of conducting civilian space activities in science and aeronautics research. I'm a strong supporter of NASA and believe that its programs help America maintain itself as the world leader in space exploration and in the scientific arenas that develop those technologies. Not only do NASA's missions inspire so many people around the world, but they also help us innovate and address challenges that confront our nation. The President's budget blueprint for fiscal year 2018 requests $19.1 billion for NASA, which is a $532.8 million decrease from the 2017 enacted level. While NASA was not cut as much as other agencies under the jurisdiction of our subcommittee, the budget proposal reduces funding for a number of important areas. I'm particularly concerned that although funding is continued for the education activities of NASA's Science Mission Directorate, this request zeroes out funding for 3 longstanding programs within NASA's Office of Education, an office that helps inspire the next generation of scientists. I strongly oppose the elimination of these programs, Mr. Chairman. I hope that we can work together in a bipartisan manner to preserve these programs that so greatly benefit the American people. I would further like to call attention to the President's request for Earth Science, which is cut $166.9 million below fiscal year 2017. In addition to eliminating several individual Earth Science missions, which are necessary in our efforts to combat climate change, the request would reduce funding for Earth Science external grants. We need to place a high priority on NASA's Earth Science research, and I look forward to discussing this topic further today. I also look forward to hearing from Acting Administrator Lightfoot on NASA's long-term plans for human space exploration, which will require significant amounts of money for research on advanced communications, entry, descent, and landing capabilities, and ways to protect astronauts' health during those long, deep space missions, among other things. All of these improvements will require a massive amounts of money over a long period of time, at a time when federal non-defense discretionary spending has been decreasing as a share of the economy. Mr. Chairman, as you very well know, I'm also a strong supporter of the Arecibo Observatory and believe that we must maintain strong support for its mission. NASA's 2018 budget request includes funding for NASA activities at the observatory, and I would like to hear more about this work. Before I conclude, we cannot discuss NASA's budget request, Mr. Chairman, without discussing the overall budget picture. As I mentioned at yesterday's hearing, I believe that we must have a serious discussion regarding budget caps and President Trump's larger budget request. The President proposes an increase of $54 billion in defense spending, funded by an equal decrease in not-defense discretionary spending. Quite frankly, implementing such a proposal undermines America's competitiveness, economic opportunity, and domestic security. Agencies like NASA are being put at risk by this unbalanced proposal, as evidenced by the unwise cuts in the NASA budget request. Our nation's leadership is a number of important areas that's threatened by this budget request, and we need to recognize that if we want our nation to be at the forefront of innovation and job creation, we need a much wiser fiscal policy. And I'm sorry for repeating myself, but I think that committees like ours deserve a better allocation as we go along, and the moving of $54 billion will hamper that in many ways. Thank you, Mr. Chairman.
Thank you very much, Mr. Serrano. Mr. Lightfoot, we're delighted to have you with us here today. Your written statement will be entered into the record in its entirety if there's no objection, and would welcome you to briefly summarize your statement, and thank you again for your service to the country.
Okay, thank you, Mr. Chairman and members of the subcommittee. I'm pleased to have this opportunity to discuss our budget, our FY18 budget request. We really appreciate the subcommittee's support, especially your bipartisan commitment to what we call our constancy of purpose in NASA. The FY 2017 Consolidated Appropriations Act, and specifically the emergency supplementals you mentioned earlier, were critical to us to keep the operations at Kennedy and Michoud Assembly Facility going. So we really appreciate that, your hard work on our behalf. NASA's historic and enduring purpose can be summarized into three major strategic themes: discover, explore, and develop. These correspond to our missions of scientific discovery, exploration, and new technology development in aeronautics and space systems. NASA missions also inspire the next generation. They inject innovation into the national economy, and they provide critical information to address national challenges and support global engagement and international leadership. The FY 2018 request of $19.1 billion supports a vigorous program that leads the world in space and aeronautics. While we had to make some difficult decisions with regard to earth science and education, this remains a good budget for NASA. NASA advances U.S. global leadership in aeronautics by developing and transferring key enabling technologies. In FY 18, we will award a contract for detailed aircraft design, build, and validation of a low-boom flight demonstrator, which will demonstrate quiet overland supersonic flight, opening a new market in the U.S. industry. In science, NASA is currently using our 20 spaceborne missions to study the Earth as a system, which supply Earth science data for weather forecasting, farming, water management, disaster response, and even disease early warning. The request also supports 2 new missions by the end of 2018. The GRACE follow-on will track water across the planet, precisely measuring Earth's gravitational field, and ISAT-2 will measure ice sheets, clouds, and vegetation canopy heights. In September, Cassini will make the final series of 22 daring dives through the 1,500-mile wide gap between the planet and its inner rings as part of its grand finale of end-of-mission maneuvers. OSIRIS-REx, on its way to the asteroid Bennu, will conduct a search for elusive objects known as Earth Trojan asteroids, and in 2023 will return a sample from Bennu back to Earth for analysis. In 2018, we'll launch the Mars InSight lander to study the interior structure of Mars, and are on track to launch the next Mars rover mission in 2020. And we continue to develop the Europa Clipper mission, which will further search for life beyond Earth. The James Webb Space Telescope continues on schedule for its 2018 launch. Webb will be a giant leap forward in our quest to understand the universe and our origins. In 2018, we'll launch the recently named Parker Solar Probe on a mission to fly closer to the Sun than any previous mission. Parker will join 18 other missions dedicated to studying our nearest star. NASA's space technology request includes investments in deep space optical comms, high-power solar electric propulsion technologies, and advanced materials. And in late 2017, both the Green Propellant and Fusion mission spacecraft and the Deep Space Atomic Clock instrument will be delivered to orbit. The International Space Station, our first step on the road to deep space exploration, is delivering the knowledge and the technology we need to keep astronauts safe, healthy, and productive on deep space missions of increasing durations. Working with our commercial crew partners, NASA plans to return crew launch capability to American soil in 2018. We're continuing the development of the Space Launch System rocket, the Orion crew capsule, and the exploration ground systems, and the technologies and research needed to support a robust exploration program. In 2019, we plan to launch an uncrewed exploration mission called EM-1 using the new Space Launch System, Orion, on a mission to lunar orbit. A crewed mission, EM-2, will follow not later than 2023. In the early to mid-2020s, we'll develop and deploy critical life support and habitation systems leading to a crewed mission beyond the Earth-Moon system. Missions launched on the Space Launch System in the 2020s will establish the capability to operate safely and productively in deep space. With your continued support, we look forward to extending human presence into deep space, exploring potentially habitable environments around the solar system, and deepening our understanding of our own home planet, pushing our observations of the universe back to the time when first stars were forming and opening the space frontier. Mr. Chairman, I would be pleased to respond to your questions and those of other members of the subcommittee. Thank you.
Thank you very much, Mr. Lightfoot. The funding levels that the committee has provided NASA over these last several years, you believe are sufficient to keep SLS on track? The delays that you're seeing are not a result of inadequate funding. They're a result of some technical challenges. Is that correct?
Yes, sir. We're struggling with what I call the normal development activities when we're trying to put hardware together for the first time. The tornado didn't help. I don't think that was a funding issue. You guys helped us by giving us the funding. But the weld schedule on the Space Launch System, some of the challenges we're having with the European Service Module in support of Orion, and some software challenges down at the Cape. They're not anything earth-shattering in my mind. They're the
Normal.
typical development activities we're having to go through. We wish we didn't have them, but we're learning as we go for the first-time build.
And you're confident you can meet the launch schedule you've laid out here for the committee for SLS?
Correct.
Terrific. We also, in the subcommittees, provided robust support for the planetary science program to ensure that NASA can maintain a good cadence of launches for the Discovery class missions, New Frontiers, and flagship missions. And does the level of funding provided by the subcommittee in 17 and 16, the level of funding you've seen over the last few years, give you sufficient funding to make sure that you can launch missions in each one of those major categories that meet the decadal survey recommendations of the?
We believe so. We've got good progress on Europa Clipper, and per the 17 appropriations, we're going to be announcing the instruments for the lander and going toward a mission concept review this summer.
How soon?
And so this summer.
This summer, great.
And so we seem to be moving really well in planetary. Helio, I talked about what we're going to do there as well. So I'm pretty confident that we've got the appropriations we need.
Okay, good. The Europa Clipper mission is extraordinarily important, and the lander has, the reason they both appear in the bill and statutory bill language, of course, is because that, as I mentioned earlier, is a place the science community believes we have the best chance of discovering life under the world. So I really appreciate the support that headquarters has given to that mission. It's going to be a turning point in human history when we discover life for the first time under the world. And in addition, it makes the SLS even more essential because a deep space mission like that with a large flagship class spacecraft that such as the Clipper and the lander require the SLS. And the lander, talk to me about the time frame for when you expect Clipper to be ready to launch and the lander.
Yeah, so in the 18 budget that we proposed, that we expect a Clipper in the mid-2020s is when we expect it to go. And of course, you know that in the 18 budget, there's nothing in there for the lander. As part of the balancing that we had to do, we had two flagship missions, the Mars 2020 and the Clipper in there. And so we got to go work the balance on that for the lander piece.
But of course, the lander's in law.
Oh, yes, and we're going to continue what we did, in what you said, what we were told to do in 17. Yes, sir.
And you've got adequate funding for it. And there's another reason that's important. The lander is important not only because when we, Mr. Serrano's exactly right, the future missions, the scale of the human spaceflight program, the SLS program, is going to require significant amounts of money over a sustained period of time. And I'm convinced when we make that remarkable discovery of life in another world, it will encourage the public, reinvigorate the public's already deep admiration for NASA, and allow us to have enough money for the program for the future. That's another important part of that Europa mission. Could you tell us about any? We were very grateful the agency has put together an Ocean Worlds program as directed by the subcommittee's bill to explore Enceladus, moon of Saturn, and Titan. And some of the other ocean worlds of the outer solar system. Could you talk to us about any, are there, for example, New Frontier, is there a New Frontiers mission being considered for Enceladus? And talk to us a little bit about why Enceladus is important.
Well, obviously Enceladus is important for the same reason Europa is. We think it's a place where we could find some of the origins of life or different life that could be there. The New Frontiers program is going to stay on its standard cadence that we'll put out here shortly, and we think we've got the money to do that.
Every other year?
I believe we're at 3 years is where we are right now, 2.5 to 3 years. But let me make sure of that. Let me get you. I'll take that one to make sure I'm exactly right. I don't want to guess here.
Is there a mission being planned to Enceladus, to your knowledge?
Well, we would put out a New Frontiers that could be a proposed mission for sure in that.
Okay, very good. Thank you, Mr. Serrano.
Thank you, Mr. Chairman. NASA's Earth Science Division works to develop a scientific understanding of the Earth and its responses to natural and human-induced changes. However, the President's budget proposal has a significant reduction in funding for external Earth science research grants. Why is this being proposed, and shouldn't research grants aiming to study our own planet be made a particularly high priority?
Yeah, so what we've done with the Earth science budget this year that we believe is the right way to approach it, we took kind of a risk management approach where we said, what's the top science, what's the decadal say, and then how are we doing from a performance perspective on the programs that are there. Plus, we took into account that the next Earth Science Decadal comes out in 2017. That can actually give us some guidance to where we may need to go because the last one was 2007. So when we made the decisions we made within the budget we had to balance all that. We still have 20 operating missions, and plus they're in space, and plus we have a large airborne science campaign. We still have our STEM science activation program going on, where we're funding folks at universities to help us with some of our challenges. So we feel like we've done the best balance we can within the budget we got.
Okay, my concern is that if the grants are currently awarded at a higher rate of acceptance, isn't that a good thing, although talented researchers are and should be doing great work studying other planets and other solar systems? Shouldn't we place the top priority on studying the changes happening in our own planet?
And we are. I mean, we're still doing some of that work. That's what I'm talking about with some of the STEM activation activities that we do in science. So we'll continue to do some of it. We won't be able to do it all, and that's what we did. When we made
Which other agencies do you work with on that?
let's see. I believe we work with NSF and NOAA to do similar work in earth science. We're pretty complementary in the tasks there.
Okay. Within the CJS subcommittee's jurisdiction, both NOAA and the NASA Earth Science Division are intimately involved in studying and tracking changes in Earth's climate. To your knowledge, did President Trump or his advisors consult with NASA's Earth Science Division or rely in any way on NASA's Earth Science data prior to the President's announcement that he is pulling the United States out of the 186th nation Paris Climate Agreement?
They did not consult with us. I cannot say whether they used our data in terms of making that decision, but they did not consult with our Earth Science Division.
And your data wouldn't have suggested that we pull out, I suspect.
There's a lot of data there, sir. I don't know if that would have done it or not.
It's a good answer. That's a beautiful answer. Administrator Lightfoot, you are aware of my interest in the Arecibo telescope in Puerto Rico, a 1,000-foot wide radio telescope used for radio astronomy, atmospheric science, and radar astronomy. Could you explain for our audience and for me some of the most important ways that NASA and the nation continue to benefit from utilizing this telescope and others like it?
Yeah, so we use Arecibo, so we use several instruments to track asteroids, near-Earth asteroids. In Arecibo, we use that to characterize. So once we identify one, we use the Arecibo, and Goldstone, for instance, is another one that we use to actually characterize the shape, what kind of asteroid it could be. So we look at it with it's almost the radar and then the characterization kind of mentality that we use. So Arecibo is an important part of that mission for us. We expect to spend roughly the same we've been spending there as we move out in the future. I think it's $3.6 million, I think is what we use there today, that we work with our friends at NSF, depending on where they go with it.
Very briefly, as a follow-up, at yesterday's hearing, NSF was basically telling us that they're trying to get away from the Arecibo Observatory. They didn't say it in those words, but we know that that's the case. Is that the same case with your involvement?
I think the way we've looked at it is we will use it if it is there, because it's the capability that we can use. But we also have other assets that actually can help us as well from characterization of asteroids.
Thank you, Mr. Chairman.
I want to join my good friend, Mr. Serrano, expressing my strong support to keep the Arecibo Radio Observatory open. It's a unique strategic asset to the country and a tremendous capability that we don't want to lose. I'm very pleased to recognize the gentleman from Kentucky, Mr. Rogers.
Thank you, Mr. Chairman. Welcome, Mr. Administrator. I've been a space nut since I was a teenager.
Me too.
In fact, when Sputnik went up in '57, it was so exciting. I quit a job in a radio station in North Carolina and enrolled in physics at the University of Kentucky, aiming for Cape Canaveral. But the first year was all, of course, all math. And I wanted to shoot rockets. I got bored with the math and switched off to something else. But NASA is more than a space launching agency. NASA is an inspiration maker, a dream realizer. the space race with the Soviets and the race to the moon, energized, inspired, excited the world, but especially here at home. And all of the spin-offs that have been caused by the space program in so many different arenas has been absolutely phenomenal. We lack that excitement today. I've no doubt, Mr. Chairman, that there probably would not have been a moonshot but for the challenge of the space race with the Soviet Union at the time. Now, I'm not advocating anything like that, but the country needs the inspiration that you and I both gained from early NASA activities. What can you tell us about building the dreams and inspiring the country?
Well, I think that there's plenty of that right now. I'll give you a great example just from yesterday. We selected announced 12 new astronauts out of the record number of applicants. We had 18,000 people apply to be astronauts, and we picked 12. About 2 months ago, we discovered potential exoplanets called TRAPPIST-1, roughly 7 exoplanets. We had 4 billion hits in our social media for just understanding what's going on there. I think that the missions we do still inspire. I think they still engage youngsters everywhere. I mean, my kids are sending me stuff that they see on Instagram and Facebook, which I'm not on, right? Asking me, Dad, what's going on here? This is pretty cool, right? So I think we still have a great presence, and I think that presence is related to the missions that we do. I think the missions, as long as we do, much like what the chairman said about when we are actually trying to make civilization-level impacts. We're trying to learn things that are going to change the way we look at everything. And those kind of missions really inspire everyone to pay attention to what we're doing. I think it's still there. Maybe not as much as it was when we walked on the moon, but I tell you, I'm pretty inspired by what we're doing, and our teams are very inspired about what we're doing, and we don't have any trouble getting any workforce to help us do it.
Good, good, good. I'm glad to hear that. The October Moon, you remember the book and the movie?
Oh, October Sky?
October
Rocket
Sky.
Boys? I think it's Rocket Boys, yeah.
Yeah, I identified very, very much with that young kid as and I'm sure you had somewhat of the similar excitement. I'm concerned about your proposed, in your budget, your cuts to the Office of Education, in fact, zero. That gets to this, what we're talking about, that the education programs hopefully have been spreading the word about NASA's excitement and all of that. I can't understand why you would want to cut that. The EPSCAR and space grant programs, 2 of my universities have used those monies to small but remarkably successful aerospace programs. Your investments have promoted high retention for Kentucky's STEM workforce. Just in April, you deployed 2 CubeSats developed by the University of Kentucky and Morehead State University as part of your ongoing educational launch of nanosatellites mission. The first time 2 Kentucky satellites, by the way, have been ever launched simultaneously, so thank you very much. But what can you tell us about the education programs that are now zeroed out in your budget request?
Yeah, so what we did is, or what we've been doing for a while is we've been doing an assessment around our outreach activities that we do and our education activities that we do, and trying to better do those a little more effectively or efficiently from an agency standpoint. What we felt was that we still have several activities going on within each of our mission directorates: science, space technology, human exploration, and aeronautics, that actually still do research fellowship programs with universities, still do STEM activation in the science community, and we felt we could balance those better. And in the decisions we made, we thought we could still do the outreach and do it a little more effectively going forward. So I don't deny that the programs have been pretty successful for us, but we felt like in the balance of things, we could do this more effectively in a different way.
Well, you couldn't beat the kind of outreach that I experienced back last August, a year ago, where the students in Leslie County, mountain area, very remote, every student in that elementary school gathered in the gymnasium and hooked up with
The International Space Station.
the International Space Station. And the astronauts did a fantastic job, by the way, for an hour. That will be in the minds of those young people from here on. And that's the kind of thing that I think we need to do more of, inspiring the up-and-comer young students who have no other way to understand and learn about what space is all about.
Yeah, I completely agree, and we will continue to do downlinks from the International Space Station with schools. That's what we do.
You've got the only classroom there is in space.
I've also got a school of your kids over at NASA headquarters right now that are in town. One of the students reached out to me directly in an email and said they'd want to know more about NASA. So it's one of the from Kentucky, and I was supposed to do that, but you guys scheduled a hearing, or I would have been talking to him right now.
Mr. Chairman, can he be excused?
Yeah, anything for Kentucky.
Thank you.
Now they're very excited though.
Thank you.
Thank you, Mr. Rogers. Mr. Kilmer.
Thank you, Chairman. And maybe just to begin, I'd like to echo the comments of Chairman Rogers. We had a NASA Explorer School in my district, and I got to visit, and the kids were mesmerized. It was really amazing. Someone presented a slide that showed a giant hole on Mars, and I joined every one of the children in walking out of that gymnasium and calling my wife and saying, "Did you know there's a giant hole on Mars and we don't know how deep it is?" And it was awesome. It was really cool, really inspiring. And I share the concern that defunding the education activities at NASA would jeopardize that sort of excitement. I wanted to ask about last Congress. I worked with NASA to write and introduce a bipartisan bill called the United States and Israel Space Cooperation Act. It was recently reintroduced, and it seeks to recognize and strengthen our longstanding and mutually beneficial partnership with Israel on peaceful exploration of space. Do you see opportunities for NASA to partner with the Israel Space Agency, and can you give us a sense of what efforts are currently underway in that regard?
Yeah, we already participate with them with our GLOBE program, AeroNet program. These are things that they participate with us on. We also see some opportunity maybe in the small-sat, CubeSat arena that we'll be looking at, and we continue to have the dialogue with them today. I would leave the aperture pretty open and see what we find when we work with any of our international partners, because we work with so many, is they have niche areas they're interested in, and oftentimes they can fill the areas that they can fill spots for us in doing those things. So I think we'll continue to work with Israelis just like we have already.
Is it correct that that during NASA's Exploration Mission 1, they'll be testing a radiation vest from STEMRAD, which is an Israeli company?
I know at one time that was in the planning. Can I get back with you on that?
I know
I definitely know it was in
I know
there.
that there's some interest in it because it helps kind of get a sense of the effects of deep space radiation on. Yeah.
Yes, sir.
I also wanted to ask about just the cost of access to space. It currently costs $15.6 million per metric ton to get to geostationary orbit with a maximum payload. If, however, you refueled a rocket in low Earth orbit en route to geostationary orbit, the price drops to $12.5 million, and the payload can increase more than twofold. Even better savings can be realized if we utilize on-orbit refueling for both Moon and Mars missions. So there's been, I think, increasing interest in using asteroids as a launching pad for that. They have the capacity to sort of unlock the solar system's economy. Can you give us a sense of where asteroid resource utilization is in NASA's exploration roadmap?
Well, of course, in this proposal, we canceled the asteroid redirect mission where we were going to bring one back. For us, what we're trying to do is understand how we can use any resource at any body, not just asteroids. How can you do it? We call it in situ resource utilization, where we can utilize the stuff that's there when we get there as opposed to bringing it with us. And so that's where we are today. I know there's quite a bit of interest in the commercial arena. We had several companies come talk to us about doing mining, let's say, on the moon.
Sure.
And to me, that's a great from my perspective, that's a great example of a public-private partnership where somebody in the private industry has an idea and we can help enable them, as we've done with some of the other things we're doing.
Last week, and this has come up in a number of the, in our subcommittees, last week Politico had an article that said the White House has been telling agencies not to respond to questions from Congress if those questions came directly from Democratic members. For example, at a hearing in May, the acting administrator of the GSA said, quote, "The administration has instituted a new policy that matters of oversight need to be requested by the committee chair." To your knowledge, has either the White House or the Office of Management and Budget approached NASA about implementing that type of policy that would prohibit
Nope.
answering questions from Democrats?
No?
Good, thank you. I'm pleased to hear that. Do I have a little more time? Let me ask just quickly, we've heard a lot about NASA's desire to enable the commercial space industry by first focusing on the commercialization of low Earth orbit. The commercial space industry has said it's important to know NASA's low Earth orbit requirements to help with their planning for future commercial space station capabilities. How is can you just talk about how NASA is working with the commercial space industry to communicate your residual low Earth orbit requirements to industry?
Yeah, there's numerous ways we're doing that. We're looking at the technologies we need to develop for us to move on to deep space. We're looking at what would require from a health and human perspective for crews. And we have a plan on the International Space Station today to retire those risks, right? And if we don't, there's going to be things that we aren't going to completely retire. So as we don't finish those things, as we move on out, we're going to need people to actually be there to help us to retire, continue to work on those risks going forward. So we have a good list. We provide it in different ways through broad area announcements, through RFIs that we put out for people to say, is anyone interested or working on a technology that could do this for us? So that's the way we usually do it from that perspective.
Terrific. Thank you, Mr. Chairman. I yield back.
Thank you very much, Mr. Jenkins. I'm going to recognize Mr. Palazzo.
Thank you, Mr. Chairman. Mr. Lightfoot, you talked about accelerating the SLS to include a manned EM1 mission. The feasibility report last month said it was technically possible to do so, but NASA decided against it. Now the SLS and Orion budgets are down and the timeline has slipped to 2019. So that leads to my question. Can you walk me through both the decision not to pursue a manned EM1 mission and the delay to 2019?
Yes, sir. So let's start with the EM1 crew decision first, if that's okay. So what we did is we asked for the feasibility piece of this. We asked several teams to get together and decide what happened. Of course, we've been doing this for a while, not expecting to put crew on EM1. So the first thing they had to do was go back for like 3 years and say, what decisions have we made that you need to reopen now that we're going to put crew on there from a risk perspective, a technical risk perspective. So we did the technical risk assessment, we did a schedule risk assessment, and then we did a cost risk assessment when we went through it. So it came out that it was feasible. I mean, we could absolutely do this, but what it cost us was it was going to cost us more. It was going to push the schedule out, and then we're going to accept more technical risk. And so really what it really did for the most part is it validated our original plan, which is we needed to do this test flight. However, in the process of doing that, we found 2 or 3 pretty critical areas that we need to do some more work on. The heat shield on Orion, there were some questions about some of the things we wanted to do there. There were some questions around some of the systems in the European service module, and we want to make sure we understood those better before we flew the first mission, even if crewed or uncrewed. And then there's an ascent abort test we were going to do after EM1 that I think we're going to pull forward now because we think it's important to go ahead and get that done. So the study itself was really good in identifying some of the critical things. As far as the date for EM1, the date crewed or uncrewed, the first date for the uncrewed mission, when the tornado came through Michoud, we were already dealing with some weld issues. We're trying to do a weld on a tank that we haven't done before, and that's just a kind of a technical challenge for us that we're working through. The tornado came through, we lost access to the area where we are, or where we're doing the welding, which for about, depending on how you look at it, cost us 1 or 2 months. Probably a little more actually when it's all said and done. And we're struggling with this weld. So the move of the date was more related to the fact that we're having the technical challenges with this weld schedule that we've got to go do. So I think that's probably the best summary. I hope I got that for you, sir.
No, that works well. And so going back to the tornadoes that went through Michoud, and because the majority of the SLS components are manufactured there, including the welding, you said, I think you just said it might be a 1 to 2 month delay. Is that all you see from the damage that happened at Michoud, or could there be more slippage?
Yeah, so we're looking at that now, right? We owe a report back probably next week, I think is when we're having the meeting. The tornado was part of it. The weld schedule is another part of it, and so we're trying to assess where that is. So the tornado wasn't the only thing. It was the weld and the tornado coming through.
All right. Apollo 17 was known as the last moonshot, and it put 3 astronauts on the moon. It launched December 7th, 1972, almost 45 years ago. There are a lot of discussions over the past few years about a destination and getting back to deep space, and the president has even talked about trying to get a man to Mars in the 2020s. Can we do this? And what will it take to get a man back on the moon and eventually to Mars?
Well, our current plan right now is we're looking at roughly, when we look at a horizon goal of getting to Mars, we look at 2033 as being a good opportunity. There's certain windows that are better for getting to Mars than others. So we look at 2033, and the way we're doing this is we're using the International Space Station today as our jumping off point where we can get all the technologies developed, understand everything that's happening in the human body, right? And then, frankly, enabling a commercial industry. We give them a destination, and we give them the opportunity to get their systems down. We'll slowly progress out and take a stepping stone process to get us out around the moon to test further systems that we're going to need. They won't be as big as we have in low Earth orbit, but they'll be systems that we can actually use, kind of think about a backbone or an infrastructure that we can then use. From there, we'll test those systems for a longer duration because we need to be good for 2 to 3 years when we talk about going to Mars. Test those systems out, and then move toward going out to the next step to Mars. So we look at the decade of the 2020s as kind of our time to prove all that out and to get those systems ready to go so that we can then go in 2033 to Mars. So it's kind of a stepping stone approach, right, that we have, and we don't assume we pretty much assume the current services that we have budget-wise today with an increase in inflation as we go forward. That's what we assume when we're making these plans. So I think that's kind of a methodical approach that we take, a systems approach to getting there, and I think it's the right way to do it.
I appreciate that response, and I would like just to mention that I do think it's important to be focusing on planetary sciences and looking out. There's already over a dozen federal agencies that study our Earth, but there's only one agency tasked with space exploration, and that's NASA. And with limited funds, flat funding, and budgets, I think our resources are better spent, exploring the deep space and not focused on
one thing I'd
what
add
other
to
agencies
that,
are already doing.
I understand, but one thing just for consideration, there's a lot of analog to learning about Earth and how it plays with the other planets, because Earth is a planet as well, and how Earth evolves. We learn a lot from learning about Earth on what could happen to Mars, what could happen to Venus. So there is a value for us in learning about Earth as well. But I understand your point.
Thank you very much, Mr. Palazzo. I'd like to recognize the gentlewoman from New York, Ms. Ming.
Thank you, Mr. Chairman, and thank you to Mr. Administrator for being here today and for all this very interesting work. As a new member of the committee, I'm learning a lot. I want to first thank you and NASA for conducting so much important research on the commercial air transportation system and flight noise situations. And I just wanted to get your take on why research of excessive flight noise and noise mitigation is important to NASA and to our country.
Yeah, well, clearly aviation travel is become a big deal now. I mean, we use it. It's gotten routine for those of us that travel a lot, and we like to say NASA's with you when you fly. There's a lot of systems on every airplane and in every airport that we've worked with our partners in the FAA to develop over time. Noise mitigation is a clear one, right? When you have so many people moving in closer and closer to airports. So we do a lot of work in our we have what's called technical challenges in our aeronautics area that work on aviation safety. They work on the environmentally responsive activities that we do, whether it's cleaner fuel, whatever it is that we use for aircraft. But they also do noise abatement as well. So all those are critical to us in terms of making sure that our aviation industry is a good neighbor for everyone what they're dealing with, but also still being reactive to what we need as customers in that arena as well. So that's what our team thinks. That's what we think our role is in that role.
Mm-hmm. For noise mitigation, from a environmental perspective or a safety perspective, why is noise mitigation important?
I think, well, noise mitigation is really that good neighbor, right? I mean, if you think about environmental is not just it's not just biofuels and things like that. It's also the noise pollution, right? And so our job is as the urban is things move closer and closer around airports, you got to be a good neighbor. And so I think that's some of the stuff we're trying to do to decrease the noise levels and help set those better.
Do you think there's more that the federal government can do, whether it's NASA or other agencies, to combat this issue of noise mitigation? I know that I have a district that is in between the two airports, LaGuardia and JFK, in Queens, New York. New York is considered to be the busiest and most complex airspace in the country. Currently, NASA invests in aircraft technologies such as the X-plane and air traffic management operations, which would limit the effect of noise and amount of time planes are spent hovering low over neighborhoods. What are you doing in the coming year to address airplane noise?
Well, like I said, we have a program and several activities in place. What I'd like to do, if it's okay, is get my team up here and let them bring you exactly what we're doing in that arena. I think that would be better than me trying to pull it off the top of my head. If I could do that, I think you would find it fascinating what the teams are trying to do.
And do you have any suggestions if other agencies could do more or to be helpful in this area?
I'm just not familiar enough to know. I mean, we work with FAA on these things quite often, obviously. They're a partner for us. But when the teams come up, we'll make sure they bring that forward, if that's okay.
Okay, thank you.
All right.
Another question, the amount of man-made debris orbiting Earth grows every year, disrupting our satellites and putting astronauts in harm's way. If current trends in space junk continue, low Earth orbit could become unusable for future satellites and missions. We heavily depend on the communication capabilities provided by these satellites, and I'm concerned about the economic impact of future space debris collisions and what that would mean for our communications infrastructure. What is NASA currently doing to mitigate space debris, and are there plans to actually remove debris? And how is NASA planning to increase these activities moving forward?
So right now, I'll take that in pieces. So today, when we launch, we have to have we have requirements that make us deorbit things, like the second stages of rockets. We have to carry enough fuel to be able to deorbit so they don't stay up there. That's one thing that we do, and everybody has to do that. But we didn't do that back in the 70s and the 60s, so there's a lot of stuff still up there. So the only thing we're doing inside NASA is we're working on technologies, very small amount. I don't want to imply that there's a big amount here, but it's a very small amount on technology and studies around what you could do. We haven't had the charter to go do that. I'm not sure that's our charter necessarily, but we know it's a risk. We all understand it's a risk going forward, but so far that's what we've been doing as far as orbital debris goes.
Thank you. I yield back.
Thank you very much. I'll recognize the gentleman from West Virginia, Mr. Jenkins.
Thank you, Mr. Chairman. Administrator, thank you for being here. Chairman Rogers referenced Rocket Boys in October Sky. I'm proud to be the congressman from the 3rd Congressional District and talked to Homer Hickam just a couple of weeks ago. So he is doing well, and we are certainly very proud of that kind of ingenuity and spirit from our state. And also similar to Congressman Rogers talking about the education area, you know, we're not Florida. We're not Texas, but NASA has a real impact. And I know we've got some of the brightest minds that not only when given a chance to compete, they win. Look at the Centennial Challenge. You're nodding. I appreciate it. You know where I'm going with this. Our WVU folks in 2014 won the Level 1 Challenge. And for those who aren't familiar with, this is where NASA has challenged the citizens, the public, to say, help us, NASA, solve big problems and issues. And you put out the marker, making it a competition, and West Virginians stepped up to the plate in 2014. WVU students won Level 1. 2015, 2016, the only team to have won a Level 2 twice. So whether it be Homer Hickam from Rocket Boys to WVU students winning national competition, there's a lot of exciting things and capabilities and talents from West Virginians. I want to go back to your opening statement where you talk about consistency of purpose. And you identified the 3 areas of influence and your kind of mission statements. And then again, Chairman Rogers raised the issue about the same concerns I have, the defunding, the elimination on this Office of Education, the EPSCoR programs, things that are so important to a state like West Virginia that doesn't have the big NASA assets, but is doing good work in support of NASA. In one of your previous answers, you said, well, we're doing this to, quote, be more efficient in a different way. And I'd like for you to explain for me a little more about how you are taking these programs that are proving very successful in my state, and are you able to reassure me that while, yes, we are zeroing out here, Evan, we can reassure you that we're going to be efficient and effective, but just in a different way, and you will continue to have that level of support. I want to understand what being more effective in a different way really means and how that impacts the programs that mean so much in West Virginia.
Yeah, I think the way we look at it in the agency is, what we found is that we have an education program, right? And we have outreach that a lot of the missions do on their own. How can we sync those together so that they actually we get a economy of scale between the two instead of them being stovepipe? And the example you used with WVU, that actually is not an education program. That was actually in our Space Technology Mission Directorate. And so we're looking at the Centennial Challenges is there, right, where the guys were working there. So we're looking at where we can use our missions more instead of a stovepiped education thing, so that we can leverage what we need in our missions and get, just like you said, get the kids engaged in solving those solutions for us. So we started this long before the budget discussion as part of our baseline services activity we've been doing, not just in education and outreach, but in procurement and human capital and other areas, to say, how can we leverage our things better and run the agency a little more efficiently? And so that's what I mean by effective and efficient. If we can start connecting the dots between what the missions need and what and the money they're already spending, and engage using some of the way we think about engaging the workforce, or the educational institutions as we go forward. Space Technology has their they have a research fellowship that's still in there. We have the science STEM science activation program that science does still, those kind of activities, and then there's a university innovation and challenges activity that's in aeronautics. So we're using our missions to fund those kind of things to engage the workforce.
Well, 10, 15 years ago, I served on the EPSCoR Advisory Board. So are you, I'm going to try to cut to the chase, are you telling me that the EPSCoR funding or type funding will still be there but from a different source? Or are you cutting out that funding and just going to be doing other things in other areas that is more efficient? My direct question is, will EPSCoR funding be there in some form or fashion and the other kind of education resources that have been provided?
Yeah, we have proposed no EPSCoR, Space Grant, or MUREP. There's nothing proposed there, and we're going to see how can we get similar results in a different way. So it's definitely not in there.
Well, I will be going to bat because I do believe EPSCoR has been very effective. That's how we are able to compete these youth. So I appreciate your directness, and again, look forward to working with the chair and the committee to try to at least advance the priorities that I think are important from a funding standpoint. Thank you, Mr. Chairman. I yield back.
You bet. Thank you, Mr. Jenkins. I recognize a gentleman from Pennsylvania, Mr. Cartwright.
Thank you, Chairman Culberson and Ranking Member Serrano. Mr. Lightfoot, thank you for being here this afternoon. I am particularly concerned about the proposed cuts to NASA's climate science programs. The administration has expressed the view that NASA should be focused on outer space and leave the job of observing Earth to other agencies, but NASA's unparalleled experience and expertise in developing new observational technologies and launching satellites makes it a crucial part of the Earth science enterprise. NASA's wealth of engineering expertise is virtually impossible to replicate in other agencies. Now, while NASA's fiscal year 18 overall budget proposes only a 0.8% cut, it proposes reducing funding for Earth science by as much as 9%. Now, to achieve this 9% reduction, which is hugely out of line with the cuts in the other part of the budget for NASA, to achieve this, funding for 5 Earth-observing missions is completely eliminated. These missions would plug crucial gaps in our understanding of Earth's complex climate and how it's changing. The first question I have for you is about OCO3. The budget terminates Orbiting Carbon Observatory 3, OCO3, which measures carbon dioxide from space. The administration's budget justification explains that OCO2 is already measuring what we need, but this isn't quite the case. OCO3 improves on at least 2 OCO2 limitations. It would be able to measure carbon fluxes at different times of the day, and it could pinpoint specific locations on Earth to, for example, measure emissions from different cities, land versus ocean ecosystems, and detect signs for drought stress in crops before such signs become visible to the naked eye. These are things that the OCO2 cannot do. Is it the administration's belief that we don't need to know where carbon emissions are coming from? Is there some other way to get that data that OCO3 would provide?
Well, for OCO3 in particular, what we did is I think I said, and you may not have been here, what we did is we did a kind of a systems engineering approach to all the Earth science missions and said, where can we get the data that's there? And which ones from a standpoint of the science, as defined in the decadals, the performance of the current performance in terms of how they're performing to get ready to fly, were the way we looked at this. And then where can we get the data from somewhere else, even if it's not at the resolution that folks want, from a risk perspective, right? And so that's how we made the decisions that we made with Clario, Pathfinder, OCO3, RBI, and PACE. I mean, that's the way we stepped through it, trying to balance the entire portfolio. We still have 20 operating missions. We still have an airborne science campaign. We still believe we're spending $1.7 billion on Earth science and have a pretty good portfolio to allow us to understand what's happening here.
All right. Next question. The budget proposes elimination of the Climate Absolute Radiance and Refractivity Observatory, Clario, the Clario Pathfinder, an instrument designed to improve a source of uncertainty in climate science, one that comes from Earth-observing instruments themselves. Clario offers scientists the data they need to produce highly accurate climate records, as well as refine and test climate projections, the kind of projections that might inform decisions on how to respond to rising sea levels, rising global temperatures, declining air quality. Clario was identified as a high-priority NASA mission in the previous Earth Science Decadal Survey. NASA has labeled the Clario Pathfinder mission a risk reduction mission. How does its elimination affect the goals of Clario and Clario's future launch? And does NASA plan to continue the Clario program in general?
Yeah, so what happened, when we did Clario Pathfinder, the reason we didn't do Clario to start with is because it was a very expensive mission, potentially over $1 billion mission. So what we wanted to do is use Pathfinder, which we can put on the International Space Station, utilize the International Space Station to do risk reduction toward the bigger mission down the road. With a new decadal coming out this year in 2017, we canceled Pathfinder to see how Clario actually ranked in this next decadal before we actually go talk about spending that kind of money going forward. So that's why we've canceled Pathfinder, to see what the decadal says coming back.
All right, thank you, Mr. Lightfoot. Now I yield back, Mr. Chairman.
Thank you very much, Mr. Cartwright. We recognize the gentlelady from Alabama, Ms. Roby.
Thank you, Chairman. Thank you, Administrator, for being here today. Great nations dare greatly, and the exploration of space is an unlimited challenge, but one that the United States dare to pursue, and an area where we've led from the 1960s into this new century. And recently, our resolve to lead in the exploration of space has faltered. And I'm very hopeful in this Congress and this new administration that we have a chance to regain the initiative and reaffirm our leadership in this space. And I share concerns that my colleagues have already shared with you, but I know with your background and in your current position, you obviously understand the important role that Marshall Space Flight Center, located in Huntsville, plays in NASA's vision and testing and operations into deep space. You've already talked somewhat at length about SLS and the missions even into the out years, so we won't go over that again. I do, however, want to talk about NASA's plan for nuclear thermal propulsion technology. And so if you could just kind of go over the scope, the schedule, and the cost of the initial tests for this on the ground, that would be very helpful.
So what we're trying to do is do some of the early technology risk reduction in nuclear thermal propulsion. A lot of it's got to do with materials. So we've got some work that we're doing in 17, in the 17 budget, I think 35 million in space technology to work on different options to get us to kind of, I don't want to say a down select, that's a little strong, but to get us to see which path we need to take, because the next step's going to be a pretty big one for nuclear thermal propulsion. We think nuclear thermal propulsion gives us an option to reduce the transit time. I mean, that's the value proposition of that, so that we can keep crews, get crews to and from quicker, right, from the radiation perspective. It also gives us some other advantages on some deeper space probes that we could use, some early looks at doing things faster. So right now it's really just a technology development program trying to knock down some of what I would call the risk associated with materials going into that.
But there are no specific target dates or a timeline that we...
Not yet, not until we understand not until we get a feel that the technology can actually be done, because I don't really want to put a date out there.
Sure,
If we don't know what's in front of us yet.
Well, just please keep us posted.
Oh, yeah.
My next question is about the additive manufacturing on rocket propulsion. And in the FY 2017 Consolidated Appropriations Act enacted just a few weeks ago, Congress provided $25 million in funding to continue additive manufacturing efforts. So what's the plan for this appropriation? Does NASA intend to allocate the entire $25 million Congress appropriated for this project? If not, why? And maybe a little bit about what NASA centers are involved and what roles they're playing here.
Yeah, so that obviously additive manufacturing is a game changer for everybody, right? It's an interesting way to manufacture stuff. From a propulsion perspective, we think there's a big advantage in engine parts and simpler engine designs. Some of our commercial folks are doing this already, right, and proving that it works pretty well. We're looking at a lot of the material properties that come with additive manufacturing going forward. We know it's in the 2017 appropriations. You'll see that when the operating plan comes up going forward. We intend to spend the $25 million on that. So that's our plan right now.
Well, it's absolutely fascinating to see, and like you said, a huge step. So with the risk of knowing that this might upset half of my constituency, I would be remiss if I did not tell you, Roll Tide. We are very proud of you and all the time that you've spent in Alabama, and congratulate you on this role and look forward to working with you down the road. So thank you again for being here, and thank you, Mr. Chairman.
Thank you.
Thank you, Ms. Roby. It's my pleasure to introduce the gentleman from Alabama, Mr. Adderholt. Thank you.
Well, thank you, Mr. Chairman. Administrator, welcome. Good to have you here today. And thank you for your many years of service to this country as an employee and manager at NASA. And I've enjoyed having a chance to work with you over the last several years. Of course, NASA is an agency whose budget has been constrained for many decades, especially when you compare it to a lot of other agencies here in Washington. So your accomplishments and your service are certainly more appreciated, or much appreciated. Americans and really, I think the entire world are very interested in your agency. And it's impossible to cover all the topics in one hearing, but I do want to touch base on just a couple things. And I want to follow up with one of the issues that we just were referring to. Some members, such as myself, voted for the NASA NASA authorization bill in 2010 with the understanding that SLS and Orion would be supported by the administration with a launch date of late 2017 or early 2018. That support turned out to be tepid with a low budget request. That bill also included an administration priority, the creation of a new space technology account. It is no easy feat for Congress to shoehorn a new account of over $500 million into a tight top-line budget. Solar electronic propulsion has been robustly funded and holds promise of pre-positioning supplies as part of a deep space mission. Its slow speed, however, makes it too slow to consider for human transport to Mars, as it was noted in the Augustine Commission. As we've just noted here with my colleague from Alabama, nuclear thermal propulsion could be added to our family of propulsion systems to provide a shorter and safer journey to Mars for human mission. And it would make more time available on mission once the astronauts arrive. Congress directed $35 million to be spent on nuclear thermal propulsion in the FY17 bill. My question, does NASA have a plan yet for focusing on those contracts on work related to propulsion, or are the funds being broken up and used for nuclear work not related to propulsion?
Well, I think we've got a plan. I can't speak at the level of detail for the contracts. I'd have to bring you that story. I probably need to bring it to you for 17. I know we're building out a plan now with how we're going to, where the $35 million is actually all being spent, and how we're actually deploying it out. So if it's okay, I'd like to take that one and bring you guys up.
Yeah, but you see where I'm going with this, and how we might could try to address that. The other thing is, I just want to mention contracting philosophy. There's no type of contract that's perfect, as you well know, and the FAR contracts have received a lot of blame for past problems. After all, it's my understanding it is possible to put penalties into contracts. FAR contracts offer opportunities to audit work and to know where the taxpayer dollars are actually spent. They offer the opportunity for companies to lodge a complaint with the GAO if competition criteria were changed midstream. OTA contracts do not offer the taxpayer the same protections. When a company has already developed its hardware with its own money and has a healthy business model, even without government contracts, OTA agreements can be helpful. Although the commercial cargo and commercial crew programs were presented by the previous administration as merely purchasing services, in reality, the taxpayer is paying 80% or more to develop hardware for the big-ticket projects. Moreover, to assume that a FAR contract would be more expensive is essentially a strawman argument. When a company proposes to take astronauts to the International Space Station for $20 million a seat, and then in 2017 the estimate is almost $60 million a seat, the question is, why is the estimate 300% off the real price? If NASA were any kind of business, someone would certainly be held accountable for a big cost estimate mistake, especially when that first price is used as a reason for abandoning a FAR contract and a transparent competition process. We need a more vigorous assessment of commercial launch programs which compare the promises to the results, not a comparison with the unsupported assumption that a FAR contract would have been more expensive. Let me say, I think that public-private partnerships are good when the private investment is openly reported and when the taxpayer is protected by real-time penalties instead of possible discounts for a service that will be in the future. So, just wanted to ask you, would you be open to creating more transparency and more reporting in regard to contracts overall?
I think for us, we use the entire spectrum of our acquisition strategy process. I mean, we have several mechanisms. We can use several vehicles, including things in the NASA FAR supplement. We're learning how to do this public-private partnership as well, right? And the kind of things that we need to learn. And I think what I would commit is we're going to learn from these, and we're going to make sure we're doing the right thing for the taxpayer on anything we do in the future. But I think there is an advantage with public-private partnerships for us to get services and even products in a different way. What we do, or what I do, I actually chair most of these discussions, is the acquisition strategy meetings where we actually decide what kind of mechanism are we going to use. And every time we bring in the lessons learned from the last time to make sure we're doing the right thing. So that's what I'll commit to, is we'll use the lessons.
Well, let me say again, public-private partnerships are good when the private investment is openly reported, and I think that's, at the bottom line, we want to protect the taxpayer. So thank you very much. I yield back.
Thank you, Mr. Adderhold. Mr. Administrator, the NASA yesterday announced the newest astronaut candidate class, 12 highly qualified individuals, as you said, from over 18,300 applicants. And we congratulate them, and I know everyone on the subcommittee joins me in saying how pleased and excited we are to be able to support them in the years ahead as they engage one of the greatest of human adventures. Given that NASA continues to recruit and train new astronauts, would you please describe the Deep Space Gateway concept, which sets a goal for human space exploration beyond low Earth orbit and which could support multiple missions in cislunar space on the path towards eventually sending humans to Mars?
Yeah, so what we've been looking at is what's the infrastructure we need, the kind of the backbone for doing this human exploration that we want to go do. So at a very much a conceptual level, we started talking about the systems we're going to need in cislunar space, around the moon, basically, that we can then use to either do work at the moon or use to progress our missions out further into space, Mars, wherever we want to go. So a simplified version of that is can we set up really it's three pieces: a habitat, a power propulsion module, and an airlock, right, is really kind of the core of this thing. And imagine it just as a node that's out there around the moon. You can go there, you can dock, you can do telerobotic operations in the moon, you can move this around using solar electric propulsion that we had from the arm. We'll move this gateway around. You can also connect there with whatever you're going to take, the vehicle you're going to go to Mars in, and you can use that as the node where you leave from there to go out. So we think it's a good structure. It offers a lot of opportunities for our international partners to engage with things they may want to do at the moon, but also to help us with what we would need to do. It offers opportunities for private industry. We have a lot of folks that have come to us and talked to us about how they could utilize going to the moon and use this as an opportunity. We're excited because the Space Launch System, the advantage to the Space Launch System and what it does, we can actually carry the crew and the pieces in the trunk of the Space Launch System because of its lift capability. So if we need to do anything, we'll have the crew there with it when we're deploying these things out in cislunar space. We really think it's the kind of that it really opens things up for us in terms of taking those next steps. So and what we've done from a planning perspective at a really high level, and we're still working with the administration on this, is we put in kind of what each exploration mission with the SLS and Orion would do and which part it would take and how we would put that in place in the decade of the 2020s. So that's our kind of our notional plan at a conceptual level, and we think it really does. It's done within the current resources we have, with considering escalation. We didn't assume anything extra. That's just kind of how we've put it together. So that's what we're trying to do from a human exploration perspective.
So the first launch of the first piece of this would be approximately when?
Well, right now we're notionally saying EM2. So when we take the first crew, we'd like to take the power propulsion module in the trunk when we go.
That's terrific. And this power propulsion module would essentially be like a solar electric propulsion
It would build right off
system?
it would build right off the bus that we had for the asteroid redirect mission.
Right.
It would build off that bus. We would probably make it smaller than we're going to have for asteroid redirect mission.
Mm-hmm.
And the smaller part is actually good for us because it gives some, it's more commercially viable for other uses of a solar electric propulsion bus. The one we were using for asteroid redirect mission was a little larger than anybody would really need for GEO or anywhere else that they want to go do. I think the advantage is that it kind of gives us, it puts us in a kind of a leadership role in cislunar where people can come work with us going forward.
In essence, you'd be assembling a smaller version of the space station in polar orbit around the moon?
We'd be able to move it where we wanted to move it. That's the
Because of
advantage
solar
of the
electric
set.
propulsion, but it would be a smaller version of the space station.
A lot smaller.
A lot smaller.
Yeah, probably just, again, just kind of a stopping point, not really a place to stay. It would be human tended, not human, and not be there the full time with folks, but people could use it.
You could also use it, couldn't you, for returning samples from deep space, from the asteroid Bennu, or from, for example, Mars 2020? It could be used to stage samples returning to Earth.
That's what we think, and then you don't have, you basically have a system that gets you from Moon to Earth, and then you have one that can go anywhere, and it becomes the hub that you go back to.
Talk to us, if you could, a little bit about Mars 2020. How's that? This was one of the top recommendations of the Planetary Decadal Survey. How is Mars 2020 mission progressing? Are there any concerns with meeting the 2020 launch date? And what are the plans for collecting and returning to Earth samples collected on Mars 2020?
Yeah, so the teams are doing great. We've had several reviews on it. We look like we're performing. The systems are, the heritage systems, you know, the ones we basically brought from the current Curiosity rover that's on Mars now, they're being put together pretty well. The instruments are having what I would call typical challenges as they go through there. We did critical design review here recently. I got an out brief on that, and things are going well. So I think we're on track for 2020, so it looks good. Mm-hmm.
Terrific. Thank you very much. Mr. Serrano.
You're on the track that I was going to lead you into already. Some of the members have asked, and the chairman has asked a lot of questions, and that's basically, what do you see as the future of NASA? The reason for that is there was an excitement that I think is missing from the public, and it might be related to man travel or, you know, man-female travel. As long as humans are on the ship, then it makes for excitement. When they're not, then it doesn't make for excitement. But at one time, that's all you spoke about. And now you have members of Congress opposing the NASA budget. In fact, I don't want to get partisan, but Vice President Pence, when he was here in the House, proposed getting rid of the Moon-Mars program. So what do you see as the future of NASA? Or does NASA have a public relations problem, that there's more going on than the public knows?
I'll probably leave this public relations part out. I'm not a public relations expert. Here's what I see the future of NASA. I think our job is pretty fundamental. We do advanced research, we lead discovery, and we gain new knowledge for this nation and frankly for the world. And part of that is extending humans further into space. Part of it is the scientific discoveries we make. And I think that's just advancing human knowledge. That's what we do. Now that may not be enough to excite people, but I think it's incredible what we do. Mm-hmm. But the other pieces that come with that is I believe NASA has a role in the economic development of this country and what we do for the industrial base that is shared by so many other folks in terms of the advances we make and where we go. I believe we're frankly a strong part of our foreign policy with our global engagement and diplomacy. If you look at what the International Space Station has done and where we are there, it's another piece that we do going forward. Our discoveries will continue to inspire. Whether they're human or scientific, they continue to inspire. I actually don't agree with that we're not inspiring people. I think we still do, just because of the people that follow us and pay attention to what we're doing. And so I think that's what we'll continue to do. We'll continue to make the civilization level discoveries that we do. That's why we're here. And I can't predict them. I can only know that we're sending the right missions based on what we're told by our advisors in the national academies on the science side, based on our advisors in aeronautics. We're doing the kind of game-changing aeronautics we need to do. And from a human perspective, it's just written in our DNA to explore. And I think as long as we're exploring, I mean, we've been on the space station for 16 straight years. That ship is tended. There are humans there. Yeah. And Peggy Whitson just passed the record for the longest amount of time in space. She's an amazing lady. And I just think we'll continue that. And she inspires folks every day is what she's doing.
How many years, you said?
We've had a continuous crew for 16 years on the International Space Station. Not the same person, but every 6 months we rotate. But for 16 years, there's been people on the International Space Station.
That's incredible.
In fact, so one of the things I like to say is if your kid just got their driver's license, most kids get them at 16, There's always been someone in space the entire time they've been alive.
Well, I'm glad to hear your enthusiasm about the future, because I was getting concerned, and so were some people I know, about how excited is the American public about the NASA program and what it means. And with some of the things you told the chairman that are in the works and the plans, it may revive what appears to have been lost. And I'll use the word appears. Secondly, let me tell you that I witnessed, as all members of Congress have, the great feeling you get in a school building when an astronaut visits. I don't know if you've ever had that experience. I mean, it's just absolutely incredible. I mean, these are heroes. This is something children from everywhere in the world understand. You know, the unknown, the space travel, the rocket ships, or whatever. And we've had, I remember we had a ceremony once where we had flown a flag, and we were presenting it to a school, and the astronaut came to present it. Well, most of the people didn't really, what did you go to today? Well, I went to see an astronaut. No, you went to see a flag being presented to a school, but it became that kind of thing. So please keep that kind of work up. And let me just ask you one last question. The administration is proposing a $36 million cut to the aeronautics account. That's what I get when I wear my glasses, which supports technological advances to our air transportation system and the aviation industry. At a time when the global economy is extremely competitive, don't you think this cut is ill-advised if we are to maintain U.S. technological leadership in the aviation industry? Also, could you explain the most recent achievements attained as a result of our subcommittee funding this account and how the American people benefit from it?
Yeah, so there's several things there. Aeronautics is a new initiative called New Aviation's Horizon, which has several pieces in it. And for the first time in, I guess I just don't know when, but for the first time we have an X-plane. I mean, this is going to be the X-plane program, which is what NASA used to do in our heyday in aeronautics. And this is, the first one is a low-boom supersonic demonstrator, or flight demonstrator. This is for us to demonstrate that you can actually fly supersonic across the United States. Today you can't do that because the sonic boom doesn't do that. And we think that opens an entire industry in this nation. And so we need to go, we NASA need to go make sure we've got the technology that allows us to do it, and then give it to the industry and let them run with it and create the aircraft they need. The other things that we do with the budget we've got is the air traffic management. Big issue with us, with our partners at the FAA. We do a great job with those guys. And the last thing I'll say that we're really working on a lot is the traffic management of drones. Our teams are working really, really hard with the FAA and building the systems that we would do to do traffic management around, you know, the unmanned aircraft systems that we or the UTM, the traffic management of these unmanned drones flying around. Our teams are leading the way there with the research we're doing. At Ames Research Center in particular, they're just doing a great job leading that. So I think that's what you're getting, and I think that's what our customers are getting, and I consider our customers our taxpayers out there.
Thank you. I'll leave you with this thought. Since I represent the Bronx, New York, if you could send the Red Sox on a long, long trip, I'll be very grateful. Thank you. Thank you. Thank you for your work. Thank you for your service to our country.
Thank you, sir.
Thank you, Mr. Serrano. Mr. Cartwright.
Thank you, Mr. Chairman. I'd like to associate myself with the remarks of the ranking member, except for the part about baseball. Mr. Lightfoot, I want to follow up. The administration is proposing to terminate the NASA Office of Education. Requested FY18 budget for the office would support only the closeout and transition of existing activities. As you did include in your testimony, the Science Mission Directorate, SMD, would continue to support certain educational activities, but not the existing programs of the Office of Education. The question is, why has the administration chosen not to support programs such as the Space Grant Consortia, the NASA-established program to stimulate competitive research, as well as the Minority University Research and Education Project.
Yeah, I think so. For us, as I said earlier, I think it's just it's a way of us for looking at more efficiently and effectively measuring our input with the community and how do we engage these students. The activities that our mission directorates do, the centennial challenges that the gentleman from West Virginia talked about earlier, those are the kind of ways that we think we can engage and still get we won't get the same. I'm not going to try to fool you and say we get the same engagement that we do with what we have today, but that's the way we're going to try to pull our outreach and education together to actually implement this new plan here. The Office of Education itself, the actual office, one of the reasons that we wanted to figure out a better way to run that instead of having it, and so that's something that's going to happen either way. We're going to figure out a way to run that differently to be a more effective delivery arm for what we want to do with our education programs. So that's the proposal that's out there, and we think we're going to try to balance the outreach and the education as best we can to still reach as many folks as we can.
And I wanted to ask you about the analysis leading up to that. Was it a determination that the Office of Education wasn't working well, or was it just we have to save some money?
A little of both.
Okay. What analysis has the administration conducted to determine the impact of ending these particular programs?
I think what we did is we looked at some of the metrics that we have related to the effectiveness of some of those campaigns that we do. And again, in the tight budget considerations we had, we just had to make some decisions around that. So that's what we did.
Can you speak to how the closeout of NASA EPSCoR being coordinated with other agencies will be affected, other agencies that have EPSCoR programs?
I'd probably have to take that one and bring you guys back that, if that's okay, because I'm not sure I know that off the top of my head in terms of exactly how they impact. I know we're coordinating with them. That's why we got the money in 18 to do that. But the exact coordination, I'd rather bring that back if that's okay.
Absolutely okay. Rather not have you just wing
Yeah.
it. Now, the proposed budget includes a steep $59 million cut to earth science research grants. And this could have a significant impact on the U.S.'s global leadership in science. Has there been a decrease in applications for these grants?
No, I think it was just, again, a balancing that we were trying to do internal to all the grants that we do. So that's where we went.
Can you speak to what extent would reducing this funding reduce the return on NASA's past investments in developing and launching earth science satellites?
Well, we still continue to launch satellites. We're going to launch 2 in 18. We still have 20 missions up there. We still have our science research and analysis activities that go on where we do where we do the research and analysis. This is just it's just a less money in that area, but we're still going to be doing that kind of assessment and analysis.
Can you talk to us about what impact the proposed reductions would have on earth science researchers and graduate students at United States universities?
I think, again, it depends on how much we have out there to provide those grants. So we don't know that complete impact at this time. We just know that we'll still have folks doing work in these areas. I can't tell you exactly what the impact would be until we implement it.
I thank you, Mr. Lightfoot, and I thank you, Mr. Chairman, and I yield back.
Thank you, Mr. Cartwright. Administrator, I wanted to ask about the cost of an SLS launch. It's a very large, capable rocket that is urgently needed to preserve American leadership in space exploration and will dramatically decrease travel time to distant destinations. The launch costs are going to be pivotal. When will that data per cost of launch of the SLS be available, and how much do you anticipate it will cost for NASA to launch an SLS with a science payload, for example?
Yeah, so we're working on what we call the production and ops mode because we're still in the first build of these. And so what we're doing is we're putting out, we've put out requests for folks to tell us what would be the production and OSCOP so we can drive that down. We expect to see that sometime later this summer. So we'll understand what it's going to be once we start a cadence of flights as opposed to this first build going forward.
Okay. What was the cost of launch of the shuttle, for example?
Oh, gosh, I'll have to get you that.
If you remember.
I'll have to get you that. I've slept a long time since then.
It's okay. Can you talk to us about the length of time it'll take the SLS to reach Europa, for example, on the Evolved Expendable Launch Vehicle.
The SLS versus an ELV? Is that what you're saying?
Yes.
It's about 3.5 years.
So it's a pretty dramatic difference.
Yes, sir.
Makes a significant difference, and that enables the scientists to do the data, see the data, and do the work that much earlier. I've got some other questions I'll submit for the record. Do you want any others?
I have one more to submit for the record.
Okay, very good. Mr. Cartwright? We are, all of us on this subcommittee, proud of the work that you do at NASA and all the fine men and women that make our space program the very best on Earth, and we look forward to continuing to support your work. And we thank you very much for joining us here today and for your service to the nation. Thank you very much, Mr. Lightfoot. Hearing is adjourned.
Thank you for your support.
Thank you.
Thank you.
Thank you.